everybody. Today we're going to work on lesson 91. Now this is something we've talked about some in the past, but hopefully we'll really get it and we can move forward. So lesson 91, the effects of scaling on perimeter, area, and volume. So as you see, I have drawn 3 squares up here, perfectly drawn, right? This one's a 1 by 1, 2 by 2, and 3 by 3. Okay, so you're using imagination. These are perfectly drawn. So let me ask you first of all, from this little guy to this one, what's the scale factor? What have I multiplied the sides by? 2, you say. Oh, good. Now what about from this one to this one? Not this one or this one. The little one to the big one. What's the scale factor? What have I multiplied the sides by? 3. Very good. Very good. So we've got a scale factor then of 2 and then of 3. So let's see what happens to the different perimeters. So let's take the perimeter of this square. What would this one be? 4 meters. Very good. What would the perimeter of this one be? 2, 4, 6, 8? Oh, 8 you say. Good. And how about this one? 3, 6, 9, 12. Very good. So do you all notice that all I have done to get the perimeter of the little one to the big one is that I doubled it, right? Little one's 4, scale factor 2 means the perimeter doubled. The little one's 4, the scale factor tripled, the perimeter tripled, didn't it? 4 getting tripled is 12. So the effect on the perimeter is the same as the scale factor, okay? Now let's see what happens to the area. Now still we're going to consider these as just like the faces, right? So what is the area of this face? It is 1 meter squared, right? 1 meter times 1 meter. So is this one going to be doubled? Is it going to be 2 meters squared? Oh, 2 times 2 is 4 meters squared. So what have we done? Oh, well the scale factor is 2, so the area is 2-dimensional. So it is going to be, the area of the little one is multiplied by the scale factor squared. So let's see what happens here. 3 times 3 is 9 meters squared. So I didn't just triple this area. I magnified it by the scale factor squared, which is 9. Hope you're seeing that. All right, let's talk about the volume. Well, first of all, I have to kind of draw a cube shape, right? Make this a cube. All right, so the volume, 1 by 1 by 1, 1 meter cubed. So here, making this a cube would be 2 by 2 by 2, 8 meters cubed, right? Let me get something out of the way here. Rewrite that. Okay. So what has happened? This cube that the scale factor's 2, the volume's been multiplied by 8. Why is that? Because it's multiplied by 2 this way, and this way. So 2 cubed is 8. So the volume has been multiplied by 8 from the little one. So what happens here? Well, again, I'm going to make it a cube. And so 3 by 3 by 3, 27 meters cubed. Okay? Again, I cubed this way, and this way, or multiplied by 3, scale factor 3. All right, so if you read through the examples, that's fine. I'm not going to go much more beyond this depth under the situation that we're in. So if you would do practice A through D, I want you to stop the video, do practice A through D, and then we will go over those. so for A, if you know the scale factor between two polygons, describe how you can find the ratio of their perimeters and their areas. So the ratio of the perimeter equals the scale factor. So if it's 1 to 3, then the ratio would be 1 to 3. If it's 1 to 5, 1 to 5. If the ratio of the areas will equal the scale factor squared. So if you had a ratio of 1 to 5 for the perimeter, then this ratio of the areas would be 1 to 25. Okay? And what do you think happens with volume? Okay, the volume would be the scale factor cubed, wouldn't it? So if they asked me the same question, it'd be 1 to 125. All right, very good. For B, the dimensions of a wallet-sized photo are 1/2 the dimensions of a 5x7. So the area then should be 1/4, right? It's going to take the scale factor and square it. All right, for C, it says a triangle that is dilated by a scale factor of 4. The area should be how many times the area of the original? Well, we'd take the scale factor for area and we would square it, right? So it would be 16. Okay, very good. And then for D, find the scale factor of the smaller rectangle to the larger. All right, so as you see on D, you have this larger rectangle. So this is 6, and then you have something in here that's 4x2. All right, so comparing this to this, what is the scale factor here? It's 3, right? 2 getting multiplied by 3 would give me 6. Remember how we do that? We say little times the scale factor is that corresponding side on the big one. So F has to be 3. Okay, so we found the scale factor. Next thing we have to do, find the ratios of the perimeters and the area of the larger to the smaller. Okay, so the ratio of the perimeters would be 3 to 1 or 1 to 3. They want you to go from larger to smaller. Okay, and then the ratios of the area, we're going to square that, so it'd be 9 to 1. All right, so refer to RenWeb for your assignment, and we'll be back tomorrow.